Hello, you're welcome back to the channel once again. I'm very happy to see you. We started with differentiation from first principle, where we are able to employ the formula with regards to differentiation from first principle, where we said y over dx equals, or is the same as f prime of x, which is equal to lim as h approaches 0 of, that's f into bracket x plus h minus f of x all divided by h. Okay, so let's see the other alternative way we can go about the same type of question. So this is how it goes. Now for this method, whatever, I want you to understand something over here. Whatever you do to the left hand side, do the same to the what? The right hand side. Are you okay? Yes. So now, wherever I see y, I will add dy or delta y, which is the same as what? Change in y. And wherever I see x, I'll put what? Or I'll add delta x. You see? So let's see how it goes. I have y equals x squared plus 1. So on the left hand side, I can see y. So I'll put what? So it will be y, then I'll add change in y. Because I've added change in y here, I have to also add a change in something at the other side of the equation. So here I have x. And wherever I see x, I'll add what? Delta x. So it will be plus what? Delta x. This x has been squared. So I'll also what? I'll also square it. Then I have plus what? Plus 1. For this method, that's how it goes. So if I have, let's say, I have my y equals 2x. So wherever I see y, it will be y, then I'll add the what? A change in y. Then when I come here, I have 2. Wherever I see x, I'll write the x, then I'll add what? Change in x. This is how this formula goes. It's not a formula though, but this is how the method goes. So I have, let me expand this. So I have y plus change in y is equal to s. This will give me s squared then plus 2x delta x. Then I have plus delta x squared. Then I have my plus 1. I hope you can expand this. When you expand this, you get this. Note, the square will not affect the delta sign. Now, for this approach, you will make dy the subject from here. So because of that, you allow this y to what? To cross to the other side. So I have my change in y equals, I'll write the whole expression here, s squared plus my 2x change in x, then plus change in s squared plus 1. Then I have my y here, so it will be minus what? Y, since I'm transposing it, minus y, right? So here, you realize that everything here is in terms of x. So I'll write y in terms of x. So I'll write, but my y from the question is what? You come here, y is the same as what? S squared plus 1. So I'll do same here. S squared plus what? Plus 1. So I'll just put it over here. So it will be dy. So that is change in y equals, I have my s squared plus my 2x delta x plus my change in delta s squared plus 1 minus y. But you realize that y here is what? It's an expression. So I'll put it in brackets. So it will be what? S squared plus what? 1. So change in y equals, I have my s squared plus 2x change in x plus change in s squared plus 1. I'll expand this, I'll get negative s squared negative 1. So clearly this will cancel that. Negative 1 will cancel positive 1. So I have change in y is equal to what? 2x change in x plus change in s squared this way. And remember, I told you that gradient is what? dy over dx. And dy over dx is the same as what? Change in what? In y over what? My change in what? In x. So that means when I have something like this, I have to make sure that change in x will divide, will become the denominator from here, clearly shown over here. So I'll do the same thing over here. I have change in y here, I have change in x here. So what I'll do is I'll divide through by what? By change in x, so that it will look like we have dy over dx. So I write dividing through by change in x. I will have my change in y over my change in x is equal to, I have 2x change in x plus change in x squared, all divided by what? By change in x. I'm dividing here by change in x. I have to also divide here by change in x. So finally, I will have this, which is equal to, when I have something like this, a plus b plus c, all divided by x. This is the same as a over x plus b over x plus c over x. They will all share the denominator in that order. So applying the same principle here, this is the same as I have 2x, then change in x over what? My denominator delta x, then plus I have here to change in x squared over what? My delta x. So clearly this will cancel this, right? So I have my change in y over my change in x equals, I have 2x plus, here you realize that this is the same as delta x times delta x. So this delta x will cancel one of the delta x here. So I'll have delta x over here. So now what do we know? You know that lim as h approaches 0 of the whole function. But we learned that h here is the same as what? It's the same as my change in x. So wherever I see my change in x, I'll put 0 there. So this is the same as lim as change in x approaches 0 of the whole function over here, of my function, will be equal to, I have my 2x, then plus change in x here is what? 0. So therefore I have what? I have my dy over my dx is equal to what? My 2x. As simple as that. This is how the alternative method works. So first of all, what you do is, the question you've been given y equals x squared plus 1. For the y side, add dy or change in y. Whatever you do to the left hand side, do the same to the right hand side. When it comes to the right hand side, we have x. When you write your x, wherever you see x, you add plus change in x. Then you just simplify. You will simplify to the extent where you make change in y the subject. When you get your final answer, what you do is, you know that gradient is dy over dx, change in y over change in x. So you divide through by change in x. So let the change in x be the denominator, because gradient is what? Change in y over change in x. So you just do the same thing here, and wherever you see change in x, it should be equated to what? To 0. Thank you for watching. Subscribe, comment, and like. Bye.